Good morning, ma'am. My name is Charanteja. I am from CSC AML second semester. Today, my topic is application of triple integrals in engineering. Triple integrals are a powerful mathematical tool used to compute volumes and other quantities in three-dimensional spaces. They extend the concept of double integral to triple dimensions, allowing engineers to analyze complex systems and solving real-world problems. In this presentation, we will explore the formulations of triple integrals and their applications across various engineering disciplines, including civil, mechanical, and electrical engineering. Mathematical formula of triple integral. A triple integral is used to integrate a function of three variables over a three-dimensional region. The general formula of triple integral is given by V integration V of xyz dv. The limits of integration define the specific region in three-dimensional space over which the function is integrated. Application in civil engineering. In civil engineering, triple integral are used in various applications including volume calculation. Engineers often need to calculate the volume of irregularly shaped structures such as dams, reservoirs, or earthworks by defining the bondages of the structure. Triple integrals can be used to compute the total volume. Ex- Explanation. Example: to find the volume of a reservoir with a complex shape, engineers can set up a triple integral based on the functions that describes the surface of the water and the boundaries of the reservoir. Mass and weight calculation. When dealing with the materials of various density, triple integrals can be used to calculate the total mass of a solid object. The density function can be integrated over the volume of the object. Example: for a concrete structure with very density, the mass can be calculated using the triple integral. Center of mass. The center of mass of a three-dimensional object can be determined using triple integration. The coordinate of the center of mass can be calculated. Application of mechanical engineering. In mechanical engineering, triple integrals are utilized in several key areas. Fluid mechanics. In fluid dynamics, triple integrations are used to analyze fluid flow and calculate properties such as mass, flow rate, and pressure distribution in three-dimensional flow feeds. Example: the mass flow rate through a given volume can be calculated. Heat transfer. In heat transfer analysis, triple integral can be used to calculate the total heat energy within a three-dimensional object. The heat energy can be expressed as Q equals to integration of V into Cp by T dV, where Cp is the specific heat capacity and T is the temperature distribution. Structure analysis. Engineers use triple integrals to determine the stress and strain distribution within their dimensional structures. This is particularly important in analyzing complex geometry and load conduction applications in engineering. Electrical engineering. In electrical engineering, triple integral find applications in areas such as electromagnetic fields and etc. Setting up triple integrals. To set up triple integrals, you need to define the region of integration, choosing the order of integration. Define the limits of integration for x, y, z. They can be done using inequalents that decrease the boundaries of the region. Dedicate the Decide the order in which to integrate the variables. Common order includes dz, dy, dx or dy, dz, dx depending on the geometry of the region. Examples of setting up triple integral. Consider a solid boundary by the planes z equal to 0, z1 equals to 1, x square minus y square, a paraboloid. At the circular region in the xy plane defined by x square plus y square, the triple integral to find the volume V of the solid can be set up as V equals to integration of x square into d x square minus y square into dz dy dx. Volume calculation. Engineers often need to calculate the volume of irregular shaped structures such as dams, reservoirs, and earthquakes. By defining the borders of the structures, triple integrals can be used to compute the total volume. Example: to find the volume of a reservoir with a complex shape, engineers can set up a triple integral based on the function that describes the surface of the water and the boundaries of the reservoir. Mass and weight calculation. When dealing with materials of various density, triple integral can be used to calculate the total mass of a solid body. The density function can be integrated over the volume of the object. For example, for a concrete structure with various density, the mass can be calculated using the triple integration. Center of mass. The center of mass of a three-dimensional object can be determined using triple integrals. The coordinates of the center of mass can be calculated. Volume of a dam. For example, consider a dam shaped like a parabolic arc. The volume of water it can hold can be calculated using a triple integral. If it if the dam's corner section is defined by the parabolic x equal to z equals to 1 x minus x square and extends along y equals to 0. Triple integrals are essential in engineering for analyzing the solving problems in three-dimensional space. They allow engineers to compute volumes, masses, center of masses, and other physical properties of objects with complex geometry. In this, we can see many engineering uh, courses apply these triple integrals for calculating masses, center of masses, and volumes of a dam. Electromagnetic magnetism. Electric charge density, magnetic fields integration uses. We can use triple integration in electromagnetism for Courses like triple E courses, they use this triple integral to calculate the magnetic field and electric charge density. Structural analysis of a dam. As I talk about the dams earlier, it can be used to calculate the dam volume, how much water does a dam contains by using the formula, sorry, uh, by the shape of the dam. For a parabolic dam, z equals to 1 minus x square and extends along the y-axis. For y equals to 0, we can use this formula to calculate the volume of a dam. Conclusion. Key applications. Importance. Future trends. Mass, fluid, heat, electromagnetism and structural engineering. These are the key points for this topic. Importance. Essential for precious problem solving and design innovation. Advance in computation, triple integral applications. Thank you, ma'am. Thanks for listening me patiently. Thank you.